Hi, Lilla. So I just want to go through and answer some of your questions from the quiz. I know you said that you had a little bit of trouble understanding how to show why each fraction bar represented each fraction. So I want to go through the first problem, 3/4 plus 1/8, and kind of walk you through that and then figure out the answer. So I've pulled up some virtual manipulatives here. These were the ones that were linked right in the quiz directions right here. In the, excuse me, not the quiz directions, in the student scenario contexts. So if you like these, they're linked right here if you want to go back and practice a little bit. So 3/4 plus 1/8. Let's take a look at this. So I'm going to start and I'm going to be using these fraction shapes and I'm going to show you how you can show why each fraction bar is worth the fraction value that we give it. So if we are going to be using this right here to represent our unit, our whole. So this red bar right in front of me, that's going to be representative of one whole. And so if I want to now make fourths, okay, because I know my first fraction is 3/4. If I want to justify why this fraction bar represents fourths, the way I do that is by comparing it to the whole. And we can see that if I took my whole and divided it into 1, 2, 3, 4 equal pieces, right? That gives us our fourths. And that's really how you justify it. You show that you can take this bar and divide it into 4 equal pieces, and those 4 equal pieces, when put together, give us back our unit, our whole. So each of these little boxes on this fraction bar has to be equal to 1/4. So if I colored one of these in, for example, right, this has to be 1/4 because it takes 4 of them to make one whole. And that's all you really need to do to give that justification. As long as the pieces are equal in size, by definition, this is 1/4 of our whole. So we need 3 of them. So I'm going to color in 2 more. So we've got 3/4. And to that, I need to add 1/8. So I'm going to pull up another fraction bar. I want the denominator to be 8. Again, it needs to be the same size as our unit. And here, I'm going to put it up here. And I could justify that this fraction bar represents eighths because we have 1, 2, 3, 4, 5, 6, 7, 8 equal size, and they have to be equal size, pieces. And if we put those 8 equal size pieces together, we get back our unit, our whole. And so each of these little boxes must represent 1/8. And so to this 3/4, I'm adding 1/8. So I'm going to choose a different color. I'll choose green. And notice I'm putting it here because this is an addition problem. I want to show that I'm taking these 3/4 and I'm adding this 1/8 onto it. And I also start to notice something. And if you're working with students in the classroom, this is where you as the teacher might take a step back and just simply ask, do you notice anything? Do you see any sort of a relationship between fourths and eighths? And hopefully, after they might need to move things around or play around a little bit. They'd probably need to line things up, but they would hopefully start to notice that 2 of these eighths fit perfectly into one of these fourths. And so these 3/4 we can also call 1, 2, 3, 4, 5, 6 eighths, right? Because 6 of my eighths fit exactly into 3 of my fourths. And so when we go through and we add up 3/4 plus 1/8, at the end of it, let's just color in what we have in all. So I'll use a different color for that. I'll use blue. So I've got 1, 2 from my first fourth, 3, 4, my second fourth, 5, 6 from my third fourth, 7 from my 1/8. So in all of this space taken up by 3/4 plus 1/8 gives me 7/8 in all. And so that would be the answer here. So when you're justifying fractions, you always want to go back to the unit, to the whole. Okay, and you want to say to your students, and honestly, fractions in the classroom, when you first start using these manipulatives, you kind of just give them to the students. You don't give them a lot. You just say, okay, we're going to talk about fractions. Each of these little, fraction bars represents fractions. You might go through and say, this is what a unit looks like. This is our whole. These are fourths. These are eighths. But you don't really tell them why. And then you sort of just have them play and see if they kind of discover these relationships. Do they notice that fourths, it takes 4 pieces to make a whole? Do they notice that with eighths, it takes 8 pieces to make a whole. And you have them build those relationships on their own when you first start out with this stuff. But you always want to make sure that they have this really fundamental understanding that when I am determining fractions, I need to go back to my unit. My unit is the most important piece of information here, because I know that my fourths, for example, I need four equal sized pieces in order to make that unit again. And that's why these are fourths. And same for any fraction. So I hope that helps a little bit. So the answer here would have been 7/8. And that's how you can go through that justification with your students. You always go back to the unit. Let me know if you have any other questions. Okay, bye.